Force and motion for IGCSE. First of all, we need to know something about the types of force. Forces are of different types and they're caused by different things. So, for example, charged particles create electric forces. You probably know that if we have a positive charge and a positive charge, they'll repel each other, and a positive and a negative will attract. So there's a force there called the electric force. So that's one type of force. Another type of force is the magnetic force. So magnets, bar magnets for example, create magnetic forces. If we put a north and a south together, for example, as I'm sure you know, they will attract, and a north and a north the force between those would be repulsive. So again, there's a magnetic force there. In actual fact, the electric and magnetic force are different aspects fundamentally of the same thing, but for the moment we can recognise two different types there, the electric force and the magnetic force. Objects with mass create gravitational forces. So, for example, if I put the Earth in space with the Moon orbiting around it, then there's a force of attraction. The Moon is attracted towards the Earth. The Earth is actually also attracted towards the Moon. Any object with mass sets up a gravitational field around that object, and we experience other objects placed in that field will experience a gravitational force. And finally, fundamental particles like protons and neutrons in the nucleus are bound together by nuclear forces. So, electric, magnetic, gravitational, nuclear forces. In fact, there are two types of nuclear force, but that's not a detail we need to worry about too much at the moment. That gives us an idea of the types of force. What do forces do? Well, they make objects move. They can accelerate or decelerate objects. You can use a force to twist or squash an object. In essence, a force is used to act on and modify the motion or shape or size of another object. When we're drawing forces, it's useful to draw what we call a free body diagram. And the idea of a free body diagram is to show all of the forces acting on an object and to focus the forces on the centre of mass, the point where we can imagine all the forces come from, which in a symmetrical object will be right in the middle. So a simple example would be if I had a book resting on a table. I'll put a little dot for the centre of mass of the book there. What are the forces on that book? You might like to pause the video, have a think, maybe sketch the diagram and add what you think are the forces, and then I'll give you my answer. So here we should have a couple of forces. We've got a force of weight downwards, which I'm going to show with an arrow there. But of course, there's a reason why the book doesn't just fall through the ground. It's being supported by the table. In actual fact, the force here is a contact force caused by electrostatic repulsion, and the table, the electrons in the table are repelling the electrons in the book, which is creating a force, an upwards force, which we're going to call a reaction force, and that's equal and opposite to the weight of the book. So we have what we call balanced forces, forces which are, we sometimes say, in equilibrium. So you'll notice on my diagram I've drawn the forces using arrows, and the arrows have shows the direction of the force, and also the length of the arrow shows us the size of the force. Now we sometimes have more than two forces. We might have, for example, an aeroplane in flight, and the aeroplane is going to have a number of forces which are acting on it. So again, pause the video, make yourself a sketch, and see if you can work out all of the forces that are on an aeroplane when it's in flight. And let's assume, for the sake of argument, it's flying at a steady height, it's not accelerating upwards or downwards, and the steady velocity. Pause the video and have a go at putting some forces on. Well, we're going to have a weight again, downwards, the force of gravity on the object. We're going to have a lift force caused by the wings, creating lift. The engines will be creating a forwards force, a thrust force. Notice that I've not put that from behind the plane. I've made all the forces focus on the centre of mass. And then, because there's some air resistance, we'll have some drag going backwards, keeping the plane from accelerating. So we've got four forces there, and again I've drawn them carefully so that the lines are of equal length upwards and downwards and forwards and backwards. We've got a plane which is in equilibrium, where the forces are balanced. Notice as well that equilibrium doesn't mean that the plane is stopped. It's travelling at a constant velocity. It's not accelerating either upwards or downwards or forwards. It's got a constant velocity because of the balanced forces. Now, the laws that govern forces were worked out by Isaac Newton and summarised as three laws of motion. And the first law simply says that an object will remain at rest or move with constant velocity in a straight line unless a resultant force is acting on it. Okay, so what Newton's first law is telling us is that the natural motion of an object is either to be stationary or to move in a straight line at a constant speed. And therefore, if you want an object to speed up or slow down, you need to have some extra force, what we call a resultant force, which is pushing it or slowing it down. So the idea of resultant force is quite important here, and we get this. The resultant force is the sum of all forces in a particular direction and here, when we add up forces to get the resultant, we have to remember that force is a vector quantity, which means that it has a size and a direction. So, for example, a forward force would normally be represented as a positive force, but a backwards force would be represented as negative. So when we're working out the resultant, we add up the forward forces and we subtract the backwards forces, the forces that oppose motion. And so what Newton's first law is telling us is that if we do that, we add up the forward force, subtract the backwards force, and they cancel each other out, so that we would say there is no resultant force, the resultant force is zero, then our object will move at a constant velocity in a straight line. The forces are balanced. That's another way we might describe it. So if I just return for a moment to my aeroplane example, here you can see quite clearly that the forwards force, the thrust, is balanced by the drag. So if I took the thrust forward, the forward force, and subtracted the backwards force, I would get zero. and the same with lift and weight. They're perfectly balanced. If I did the lift, subtract the weight, I would get 0. So we have balanced forces upwards and we have balanced forces forwards. So we have equilibrium, we have constant velocity. And so Newton realised that an object will move in that way, and that the only way to make it accelerate, to change its speed, is to have what's called a resultant force, when there's more forwards force than backwards, or more upwards than downwards, shall we say. So think about another example. Let me give you a case and see if you can explain what's going on here. So I've now got a car moving along the road. And it's moving with a constant velocity of, let's say, 10 meters per second, a steady speed. Okay, and I'd like you to make a drawing of that and add to it all of the forces and explain whether or not the forces are balanced and how you know if they're balanced. So I'll pause the video and have a go at making that drawing, add on the forces and explain whether or not they're balanced. Okay, so let's first of all put some forces on there. The forces in this case are the weight downwards,